Be really careful here. It's easy to do the wrong plan. It's easy to find the least common denominator and then just assume we're going to use it as a target to change all the fractions into ones with common denominators. And that's not what we're going to do. This is an equation. And when we solve the equation, we're going to do something else with the least common denominator. So just be really careful, because it's easy to make a mistake here. So in order to find the least common denominator, it's a good idea to factor all the denominators. We've seen that before. This looks like x plus 4 times x minus 2, which is kind of nice because we have an x plus 4 and an x minus 2. So now we're going to take the least common denominator, which is x plus 4 times x minus 2, and we're going to multiply it through on both sides of the equal sign. So a copy is going to go here, a copy is going to go here, and a copy is going to go here. We're going to take this guy, we're going to multiply it on the left-hand side, distribute it here and here, and on the right-hand side, put it here. And its job is to go through and cancel these denominators. That's worth pausing and thinking about. Its job is to cancel the denominators. Now I can't even see that, let alone expect anybody else to see it. So let's watch it do its job. This is supposed to be able to cancel this denominator. There they go. And we have 2 times x plus 4. Here they go. And we have 1 times x minus 2. Here, these guys go, and I like that side. It's just an x. Now distributing, we have 2x plus 8 plus x minus 2 equals x. Taking an x away from both sides, we have 2x plus 8 minus 2 equals 0. 2x plus 6 equals 0. 2x equals negative 6. X equals negative 3. Now negative 3 ought to work. We ought to be able to check it. Checking negative 3 by putting it in and calculating everything is optional. But checking negative 3 to make sure that these fractions are defined when x equals negative 3, that's not optional. Negative 3 is the only answer we can have, but it doesn't work if it makes a denominator 0. So it's your job to check and make sure that none of the denominators are 0. Checking this denominator when x is negative 3 here, this isn't 0. When x is negative 3 here, this isn't 0. This one would be sort of hard to calculate what happens when x is negative 3. So use this version. We factored x squared plus 2x minus 8. We factored it into x plus 4 times x minus 2. So I don't really know what just happened. So, will x make this denominator 0? Will x equals negative 3 make it 0? No, negative 3 makes this be 1, and negative 3 makes this be negative 5, and 1 times negative 5 isn't 0. So it's safe to say that our solution, negative 3, does not make any denominator 0, therefore it doesn't make any fraction undefined, and therefore if we did correct work, this is the right answer and we can circle it and be done. And I expect that's what you should do. I do want to show you, though, that it could be checked if you needed to. Putting in a negative 3 here for x, we get negative 3 take away 2, that's negative 5. Putting in a negative 3 here for x, we get negative 3 plus 4, that's 1. As I already mentioned, first we get negative 3 when we put it in for x here. And when we put in negative 3 down here, we get 1 times negative 5, or negative 5. So the question is, does negative 2/5 plus positive 1 equal positive 3/5? A negative divided by a negative is a positive. And the answer is yes. Negative 2/5. 1 can be thought of as 5/5. It does equal 3/5 because negative 2 plus 5 is 3. This kind of checking is optional and very few people do it. Most students seem to think it's easier just to be really careful with the work and make sure you don't make any errors than it is to try to do all this fraction work. But on these problems in section 6.6, you have to check to see if this solution makes any of the denominators 0. If it does, then you put no solution. Since this didn't, this is the solution. And we're done. So here I started with the problem 3 over x minus 4 equals 5 over x plus 1. I multiplied both sides by the least common denominator. These x minus 4's canceled and I had 3 times x plus 1. Here the x plus 1's canceled. I had 5 times x minus 4. I distributed. I subtracted 3x from both sides, added 20 to both sides, ended up getting x equals 23 halves, or 11 1/2, or 11.5. I need to make sure to remember checking to see if this makes the denominator 0, but the two denominators, original denominators, were x minus 4 and x plus 1. The only x number that makes this 0 is 4. We didn't get 4. The only x number that makes this 0 is negative 1. We didn't get negative 1. So 23 halves, or 11 1/2, or 11.5, they're all different versions of the same correct solution to the original equation. Now I wanted to show you one other thing about this. So I'm going to scroll. We have 3 over x minus 4 equals 5 over x plus 1. When there's one fraction on each side of the equal sign, nothing else, not two fractions being added, not a bunch of other stuff being subtracted, but just a single fraction equals a single fraction, you're allowed to cross multiply. If you cross multiply, 3 times x plus 1 will have to equal 5 times x minus 4. And if you look at this, you can see that that's what I had when I multiplied both sides by the least common denominator. So it's just about the same kind of work. But many students find that this is easier for them when there's a single fraction on each side to just think of setting the cross products equal to each other and then going ahead and doing the same steps we did up here and getting the same answer, 23 halves. So I wanted to mention that on some of the problems you can cross multiply.